Okay, so for this video, we're going to talk about the calculation rules of exponents. And let's get into it. So for traditional calculation, like we have 5 times 3, we got 15. We times those numbers directly to each other. But in this case, it's a little bit different. When we times a with power of m with a with power of n, we get the exponent that add each other. The base is the same, remember, the base is the same, but we add the exponent. So addition, no, we can write that multiply is actually become addition. So multiplication, addition, and here division, we can see division become subtraction. Oh wow, subtraction. Sorry, let me turn on that. Okay, become subtraction. And pay attention to the order. The n is in numerator, and that goes first. The n is in the denominator, that go last. So remember that. So let's give a clear example, like x with power of 3 divided by x power of 2. That will become x 3 minus 2. Remember, numerator minus denominator. Okay, that will become x. Yeah, of course. And so division becomes subtraction. And following on, we got some bracket things. So if today the exponent is outside of a bracket, then what you do is actually you time them. So let's become multiplication of components. Okay, and these two are actually something that we might forget. Just keep in mind that when you got exponent of something that is in bracket, you do same thing to each element inside of it. So in this case, it's a, b in this bracket. So a will have n as its power, and b also got n as its power. So that will become this. That is a with power of m times b with power of m. And that also works for rational expression. So a divided by b, and with bracket with exponent of m. Then your denominator will have m as its exponent, and your denominator will also have m as its exponents. Okay, and that's all property. Let's go through it really quick. So a with power of m times with a with power of n, that will become a with power of m plus n. And a with power of m divided by a with power of n will become a with power of m minus n. And with bracket, a power of m bracket of power of n, that will become a with power of m times n. M times I believe you guys can understand what I'm talking about. Okay, and a times b with bracket and power of m will become a power of m times b power of m. And a divided by b bracket, don't forget bracket, that's really important, power of m will become a with power of m divided by b with power of m. Okay. And next is small tips that I wish you guys can keep this in mind, that will help to ease your calculation. So let's say we got minus a in this bracket, and we got n as exponent. And if n is an even number, okay, so like 2, 4, 6, 8, blah blah blah, something like this, then you can write minus a power of n become a power of n. The reason is, let's see this. You just consider this become minus 1 times a. So let's focus on the minus 1 part. Minus 1 with n, and then we know if n is even number, then you got even negative 1 times each other, then you got a positive 1. Okay? And same case, if n is an odd number, that means you'll get minus 1 times minus 1, and there will always be another minus 1 left, because it's an odd number. It can be an even number plus 1, like 3 is 2 plus 1, and there are 2 minus 1 here, and the other minus 1 will be left, so you always have to leave the minus sign here. Okay, so you got minus a minus negative a with power of n, if n is an odd number. Okay, so the point is about negative 1, not a, because a with power of n is always there, here, and here. So do you have to leave negative? It's based on how many times you time this bracket. Okay, and that's for theory and the knowledge. Let's get into the exercise. So first one, what we got, first one we get is 7 with power 4 times 7 with power 6. And so we look back to what we write here. Let's give them some mark. 1, 2, 3, 4, 5. Okay, there are 5 properties we got. So we're going to use this one because they are doing multiplication. And what we can see here is there will become addition of exponents. So let's keep the base here the same. Base is 7, and we do addition. That will be 4 plus 6, because 4 from here, 6 from here. Then we got 7 with power of 10, and that will be our answer. We don't have to call a calculation, and we don't have to use calculator. Yeah. And for next one, let's look at this question B. 9 with power of 14 divided by 9 with power of 6. So let's look back at here. Division is subtraction of the exponents. So let's do the same thing here. We keep the base is 9, and then we do subtraction of the exponents. We got 14 minus 6, okay, and the value of 14 minus 6 is 8. So you can write your answer this. But if you want to represent it with the least base, because we know 9 is 3 squared, you can write so from here 3 squared power of 2 and no power of 8, that will become 3, and remember that this 2 is the property 3 here, one with exponent and bracket another exponent, that will become 16, because it's 2 times 8, and that will become 16. Yeah, so either way it's correct, or you can choose to calculate that number, but that would be a heavy work. Yeah, so let's avoid that. Next is the same, so we keep the base is r, and then we got 9 minus 17 for the exponent. So always remember numerator minus denominator. Okay, so we got 9 minus 17, that will become negative 8. Okay, so negative 8, and that will be our answer. Yeah, and next one, what we got, so let's look back to the above. We can find this one. Let's consider 2m as a, so 2n is a, and here the exponent inside the bracket is 3, the exponent outside the bracket is 4, and then we just times the exponent together. Oh, okay, so actually we forgot one thing, that in this case 2 and n with power of 3, they can be considered with 2 elements, so we will use both property 4 and property 3. Okay, so let's start with property 4, because we have to remove the bracket. So first we have to know that we got 2 is an element, the other element here is n with power of 3 here. Okay, then we got 2, and remember each element inside the bracket will get the exponent outside the bracket. Okay, so 2 is first element here, we got the exponent outside of it, and then we times the other one, m3, n with power of 3, and the exponent. Okay, then let's keep doing that. So for first part here, we have to calculate 2 with power of 4, and 2 with power of 4 is 16. If you can get it, you can times 2 4 times, but yeah, if you can do it directly, you can times 2 4 times, and then you'll get the number. And next part here, we're going to use the property 3 we got up there. So property 3 tell us, okay, inside the bracket we got a exponent, outside the bracket we got another exponent. When we are doing the calculation, the base is the same, we multiply the 2 exponent, one inside, one outside. So here we're gonna times this, and 3 times 4, the exponent inside, inside, outside, outside, we time them together. Okay, then we just move them together, 16 m, and 3 times 4 give us 12, so it's n times 16 with power of 12. Okay, let's turn this into black, and that will be our final answer for this question. Okay then, let's keep going on. This one, okay, this one will only use, okay, this will use property 4 up there. Property 4, we got 2 elements in a bracket, and we got exponent outside of it. So let's do it. First element we got is 3. Another is x, so we do it one by one. First is 3 power of 4, and then we got x power of 4. We time them together. Okay, move this dot a little bit right. So 3 with power of 4, that will become 9 with power of 2, and that will become 81. Okay, 81. And here we got x with power of 4. We just directly write it. So we can write x with power of 4. That would be our answer. Okay. Next, okay, is property 5 here, because there's a rational expression outside the bracket. We got the exponent. What we did is both numerator and denominator got the exponent. That's all. So let's do it. We got 2. One is the numerator, one is denominator. Let's do it. So first, draw this line. The numerator is x squared. We give it the exponent 6, and then it's the denominator y with power of 3. We also give it the exponent. Then we're gonna to use property, I think, 3. Yeah, this one. You'll get familiar with this. One inside the bracket, one outside the bracket. Outside the bracket. You multiply them. Okay. So here, let's do the numerator first. So 2 times 6. 2 times 6. And for the denominator is 3 times 6. And it's really easy for you guys. Okay, 2 times 6 is 12. 3 times 6 is 18. Okay. And that's it for this one. And then we got this. This one is a little bit harder if you look at it in first glance, but the way we do it, we cut it into half in the middle. Okay, so we're gonna to write in this way. Here we got a minus 3, a with power of 4. Okay, and then we use a multiplication sign to connect them. B with power of 5 and b with power of -7. So now we can treat it as 2 different elements. One is this term, one is this term. But remember, they are connected to each other by multiplication. Okay, and this gives us back to the property 2, which is division. And it will become subtraction. Just remember, numerator go first. Okay, so here we got first one. We keep the base a, and we got -3 is from numerator minus the number in the denominator is 4. Okay, and times with b, the base, numerator, and the, what's that called, denominator. Okay, in case you guys can, my writing is too hard to see, I write 7 again. Okay, so here we get a minus 3 minus 4, that will become minus 7, and then we times with b, that is 5 minus negative 7, and we know that will become addition. So that will become 5 plus 7 is 12, and this will be your final answer. Okay. Then next one, okay, it start to become harder, but yes, we can do it. So in this first scan, we could not tell how to calculate. It looks like it's already calculated. Yeah, but actually, we have to go a little bit forward to recall that negative part, negative exponent, means that you put your base to the denominator. Okay, so we're going to use this property. We can rewrite p with power of negative 1 into 1 over p, and we can rewrite q with power of negative 1 into 1 over q. And here, what we get is this, and then we can try to write them into one rational expression. Okay, and here for the denominator we'll time each other, so we got p times q, and then for the numerator we got q plus p. And how could we got this? Let me explain this. P 1 over p plus 1 over q, we can write it into pq. Okay, we times q to first term here, this is time, okay, and we times p to second term plus pq p. And we know that the rational numbers, they can only add or subscribe when they got same denominator. So they got same denominator, now we add them together, so we got this term. Okay, from here to here. Okay, then let's keep going. That will give us actually just this answer, pq over q plus p, and that's our final answer. Yeah, you can just write at this stage and just do this. That'll be totally fine. Okay, let's erase. Okay, let's leave it there, it doesn't matter. And following up, we got another one that's harder, but same way, actually same way of thinking as question H. We use this concept here, but don't freak out, it's not that hard. Okay, so first, for the numerator, we got x squared, 1 over x squared minus 1 over 1 y squared. Okay, because the negative sign of exponent is telling us that we have to flip the number. Okay, and then this one will become 1 over x minus 1 over y. And next step, what we're going to do is, for the numerator, they time each other in the small numerator here, and then we got y squared minus x squared. Okay, because you times y squared to this part, x squared to this part. Actually, you times y squared, x squared, x squared, and then you got this. Yeah. And for this one is just x, y minus x. Yeah, just a PQ up there, up here. Okay, and then not end yet. We have to make them into a easier form. So what we can see from here, y squared minus x squared, and then we got x squared y squared, x squared y squared. And remember before, when we have to do this kind of calculation, we have to flip the denominator to do this calculation. So we'll flip, so we got xy and y minus x. Okay, and at this step we can find that they got some common factors here. So here we got x times x, y, and we got xy here. So actually we can eliminate one y and one x. So let's do this. No, use blue. Y and y, x and x. So this will become xy, and I will keep xy alone and put y squared minus x squared here, y minus x here, because we also have to recall another thing, is that y squared minus x squared, we can rewrite it into y minus x times y plus x. Remember that? Okay, so we write this, and then we write this, y minus x, y plus x, and we got y minus x in the denominator. We can eliminate y minus x. Therefore, I got no space, so I have to move this a little bit here. We can finally got our final answer, which is xy with y plus x. And that will be our final answer. Wow, so much, right? And for the last part of this video, we just do some figure calculation, no more variable. Okay, so here we got 121 with power of 1 over 2. That means actually it got some meaning of this thing. Okay, so how can we find that? We use this short division, and we try to find the factors of 121. So the first one I found is 11, and then 11, so right 11 here, it got 11 left, 1 left, so it's 11. Okay, so we can tell that 121 is 11 times 11, And guess what? This is our square root. So we can write this is equal to 11, since 11 squared is 122. Okay. But this is not part of the answer, only this. Okay. So this one, we do the same thing, 625. Okay. So we want to find its factors. We know any number that ends with 5 or 0, it got factor of 5. So I will use 5 here. And we divided 625 by 5. So first digit is 1. And then we got 1 left. And so there will become 12 here. We use 5, so we get 2. 2 times 5 is 10, so we got 25 left here. And we can tell it's 5. Okay? And it still ends with 5, so we're going to do it again. Okay, so factor 5, and we want to know what times 5 will give us 125. So we got 2, 5, 25. Okay, so it still ends with 5. We can keep going. 5 times 5. Okay, and then we found, okay, 5, 1, 2, 3, 4. There are 4, 5 in here. So 625 is actually 5 times 5 times 5 times 5. So that is 5 with power of 4. So we can write this as 5. Okay, then 256 divided by with power of 1/4, and that will become this. So that's doing the same thing, short division. This time I would like to guess 4. Okay, 4 times 6 is 24. And we got 16 left, so 4. And then here we got 4 again. 1. We got 24 left. 24 is 6. Okay. 4 times 6 is 24. And then we got 4 and 4. Okay, so we got that 256 is 4 power of 4. So when we do 256 with power of 1/4, that will become 4. Okay. So actually the calculation between this from here to here is we all write 1/4 exponent to each side. And on right hand side, because they times each other, these two, they times each other, so we can eliminate the part from numerator and the denominator. Here's numerator, denominator. So we got 4 left on the right, and here is the same from here. Okay, and for this part, 64, we want to find its factors. So actually we know it's 8 times 8, right? We should write 64 is 8 times 8. And we know 8 is 2 with power 3. Yeah, 2, there are 3 2's, they times each other. So 2 with power 3, 2 with power 3. And then we put them together, we got 2 of power of 6. 2 with power of 6. So we can write this will become 2. Okay. And then last 4. Okay, hold on. So 27, we can write 27 as 3 times 9. Or we can write 9 as 3 times 3. Okay, so we can find that there's 3 in 27. So when we do 1 over 3, we can get that is 3. And here, okay, negative 32. So we can write negative 32 into negative 2 times negative 2 times negative 2 times negative 2 times negative 2, right? 1, 2, 3, 4, 5. So when we times this 2 will become 4, and 4 times this one we will get negative 8. Negative 8 times negative 2 will give us 16, and this time negative 2 will give us negative 32. So yes, that's correct. We can write this is negative 2. Remember the negative sign. Okay, here. Okay, so we can write 128 and try to find all its factors. I'll use 4. Okay, 4, 3 is 12, 2, 8. Okay, so another 4, we can get 8. So we can know that 128 is made by 4 times 4 times 8. And then 4 is 2 with power of 2. 4 is 2 power of 2. 8 is 2 with power of 3. And then we add those 3 exponents together. We get 7. So that would be 2. Because we got 7 here. And it's divided into 7. Okay. And last one. Okay, so we pay attention to this question. Is 1 over 2 for exponent, but its base here is negative 49. So what this means is negative 49 square root, but we already know that anything inside the square root, because today we got 2, so that means 2 numbers they times each other. 2 same number that time each other will become negative, but that's impossible, because if 2 numbers they are all positive, like positive 2 and positive 2, they will give you 4, right? If you got negative 2 and negative 2, they will give you still 4, because the negative 1 has 2, so they will be turned into 1. So there's no any possibility that 2 same numbers that time each other will give you a negative number. So for this one, we can only write no solution. Okay, this is our answer, no solution. So we should write in black because that's how we answer, no solution. Yeah. And that's all for today. Exponent. Thank you for listening.